Alrighty, in example 2, we're going to work backwards from what we just did. In example number 1, I gave you the vector in coordinate form. I said, here's A, here's B. Find the magnitude and find the direction. Well, in example 2, as you can see, I'm giving you the magnitude. Vector W has a magnitude of 25. I'm giving you the direction. It has an angle. The angle we're talking about is 41.7 degrees. Let's find the horizontal A components and the vertical component B. All right, so we are looking at the horizontal component A, and we want to find B. Well, how? Thank you for asking. So if we look at our grid, I love our pictures. We have vector W. It has a magnitude of 25. It has a length of 25. And from horizontal, we are going to go up 41.7 degrees. So from horizontal, we're going to go up 41.7 degrees-ish, and that is a magnitude of 25 and an angle of 41.7. And what we are looking for is A, and we are looking for B. I'm hoping you're getting super good at drawing these triangles by now and understanding what they're telling us. Alrighty, so we've got an angle. I've got the length of the hypotenuse, and let's find A first. Why A first? Because it's first in the alphabet. So I've got an angle, the hypotenuse, and A is the adjacent side to that angle. That's going to be cosine. Cosine is adjacent over hypotenuse. So the cosine of 41.7 degrees equals A over 25. Get A by itself. I'm going to multiply both sides by 25. So we're going to have the 25 times cosine 41.7. That's going to be A. I plug all of that into the calculator, and we find A is about 18.7. So my horizontal movement is about 18.7. Now let's find B. We don't want to use A because I rounded A. Let's go with what they gave me. I've got hypotenuse, I've got this angle, and I want to find the side opposite that angle. So that's going to be sine. The sine of 41.7 is going to equal opposite, B, I don't know what it is, over the hypotenuse, which is my magnitude. Again, multiply both sides by 25 to get B by itself. And that's going to be B. Plug all of this on the left side of the equation into my calculator, and we're going to find out that B is about 16.6 up. All right? So that's not so bad. Now, let's see if we can figure out a shorter way to do this than all of that. So if you go back a step or two in both cases, let's look right here and right here. How do we find A and how do we find B? Well, if you noticed, A, did you figure it out? A is going to be the magnitude of my vector times the cosine of my angle. And B is the magnitude of my vector times the sine of the angle. So you can take AB, vector form AB, component form, and we can literally say A is the magnitude of the vector times the cosine of the angle, and B is going to be the magnitude of the vector times the sine of the angle. Boom. So that's a nice, quicker little way to write our forms. Boom. Easy peasy. Well, what if we go back at example 3 and let's take the vectors u, v, and w and write them in component form AB. So when I'm done with my components, I want them to be a point A and a point B. Well, what we just said when we have values like this, we said we can find AB by saying the magnitude of my vector times the cosine of the angle is A, and the magnitude of the vector times the sine of the angle is B. So let's start with our first one, U. To find U, we are going to take the magnitude of U, its length, which is 5, and we are going to multiply it by the cosine of the angle, which is 60 degrees. And then we are going to do 5 times the sine of 60 degrees. And we're going to write our answer in component form. So let's find out what cosine 60 is. Well, the second line up on my unit circle, boom, boom. This, the third line up, I'm sorry, this would be at the point, oh, my bad, 1/2 radical 3 over 2. 1/2 radical 3 over 2. So cosine of 60 is 1/2. Sine of 60 is radical 3 over 2. So the A value is going to be 5 times 1/2, which is 5/2. And 5 times 3 radical 2 is 5 radical 3 over 2. And there is the component form of vector U. Now let's find the component form of vector V. It's in red. So again, V is going to be the magnitude of the vector times the cosine of the angle, and the magnitude of the vector times the sine of the angle. Sorry that I'm bleeding into the picture. Well, this over here, we are at the point -1, 0. So 2 cosine of 180 is -1. And then 2 sine of 180 is 0. So vector V is going to be at -2, 0. Oh, and one more. One more. We're going to find W. Let's write vector W in component form. Okay, so we are going to take the magnitude times cosine of 280, and then the B value is going to be magnitude times sine of 280. Now I know what you're thinking. Well, hey, wait a minute. 280 isn't on the unit circle. Your 180 was on the unit circle and 60 was on the unit circle. And I'm like, you're right, 280 is not on the unit circle. So we get to use our calculator. So in our calculator, I'm going to do 6 times the cosine of 280. And that's going to give me about 1.0419. I just went out to 4 decimal places. And then 6 times the sine of 280 is -5.9088. And then you can verify, do we go to the right and down? I did, so that looks pretty good. All right, so that is how we can do some of our arithmetic and writing out and understanding what our vectors mean and how to read a vector and the difference between a vector and a point and how a point relates to a vector. So if you have any questions, please come in with those questions. Love to help you, and I'll see you when I see you.